Hello, welcome to Chapter 4.3, Solving Literal Equations. Now you may ask, what is a literal equation? A formula is a type of literal equation because it contains constants and more than one variable. We can use equation properties to change formulas to better meet different situations. So, for example, 3x plus 2y is equal to 6. Well, remember, this is a linear equation, and this is in standard form, as we saw before. This equation can be solved for either x or y. Now, remember, when we solved this for y, we were able to find the slope and y-intercept of the line, where when it's like this, there's not much we can say about this line. In examples, we are told which one to solve for, x or y, but usually we have to solve for y. Other literal equations or formulas that you may have seen before is P equals 2L plus 2W, which means the perimeter is equal to 2 times the length plus 2 times the width, or the distance is equal to rate times time, or area of a triangle is equal to 1/2 base times height. You can solve for any of the variables in any of these equations. In example number 1, we're asked to convert 23 degrees Fahrenheit to degrees centigrade. And this is an example of a literal equation because we have two variables. We have centigrade and Fahrenheit. But in this case, we really just have to plug in the Fahrenheit to find the answer. And let us do that. So we have C is equal to 5/9, and we have the Fahrenheit is 23 degrees, and we have to subtract that from 32 degrees. And then we find that C is equal to 5/9 minus 9. And then we put -9/1 to make the solving of the fraction easier, and we find that this is equal to -5 degrees centigrade is the same thing as 23 degrees Fahrenheit. Now, sometimes you're not given that information and you actually have to solve for the variable itself, just like we did with the linear formulas before. So let us look at example number 2. Using the formula distance is equal to rate times time, or d is equal to r times t, we can solve the formula for r or t, given d is equal to rt. So let us solve for r. So I'm going to go to the whiteboard and show you how I would solve this for r.
In example 2, we are given the formula with all these different letters. D for distance is equal to rate times time. So what we want to do is we want to solve for r. So what we do is we do the same procedure as we would do for a regular algebraic problem. So that means we would look at D is equal to R over T, and we divide by T on this side and divide by T on this side so that we can isolate the R, just as we would if T was a number. So we cancel out the T in the usual way, and this means that R will be equal to D over T.
Reviewing what we did on the whiteboard, we found that we had D is equal to RT, and in order to isolate R, we had to divide everything by T. And we ended up canceling out the T the way we would a regular algebraic problem. And we found that D over T is equal to R. In example number 3, we're asked for all B and C and A not equal to 0. If AX plus B is equal to C, then what is X? Let us go over to the whiteboard and figure this out.
In example 3, we have AX plus B is equal to C. And we want to find what X is. And again, we go through the same type of procedure as we would if instead of A, B, and C, it was numbers like 1, 2, or 3, or 4, 5, or 6, or 2,537, 4,400, and 3. We'll just go about it the same way as it would be with numbers. So what we want to do is we want to ultimately isolate the X. So the first thing we'll do is we'll subtract B from both sides. And that means we will get AX is equal to C minus B. Now we have AX, and so what we want to do is divide by A on both sides, just as we would if it were numbers, and we cancel that out. And so X is equal to C minus B over A.
In example number 4, we're given P is equal to 2L plus 2W, and we're asked to solve for W. So let us go over to the whiteboard and work this one out.
In example 4, we have P is equal to 2L plus 2W. And this is the formula for the perimeter of a rectangle. And in this case, we want to solve for W. So again, we'll treat everything else but W as though it were regular algebraic numbers. So here we go. So what I will do to isolate the W, first thing I'll do is subtract 2L from both sides. So then I end up with P minus 2L is equal to 2W. And then I will divide both sides by 2 as though it were a regular algebraic equation. And then I end up with W is equal to P minus 2L all over 2. And that would be my final answer.
Reviewing what we just did on the whiteboard, we subtract 2L from both sides, and we end up with P minus 2L is equal to 2W. Then, in order to isolate W, we divided both sides by 2. And we got P minus 2L over 2 is equal to W. In example number 5, if S is equal to P plus Prt, solve for T. So let us go over to the whiteboard and work this one out.
In example number 5, we have S is equal to P plus Prt. And they're asking us to solve for T. So in this case, we do the same type of thing. We could just bring the P over here. We can't combine a P and an S. We can just represent it as S minus P is equal to Prt. And then, in order to isolate the T all alone, we can divide both sides by Pr, and there we can cancel out those two. And then we're left with T is equal to S minus P all over Pr.
Let us review what we just did on the whiteboard. We move the P over to the other side to get S minus P is equal to Prt. And then we isolated t by dividing by Prt on this side and on this side, so we got S minus P over Pr is equal to t. In example number 6, we're asked to solve the following equation for R. A is equal to P times 1 plus RT. Let us go over to the whiteboard and work this one out.
In example number 6, we will have the equation A is equal to P 1 plus RT. And we're asked to solve for R. Well, R is trapped inside these brackets, and that's why there is the hint of the distributive law. So let's free up R and get it out of the brackets so that we could solve it algebraically. So I'm going to multiply through everything through by P, and I will get A is equal to P plus PRT. And again, here we are asked to solve, in this case, for R. So as mentioned, just bring over the P the way we would a regular algebraic situation. A minus P over P RT. And then to get R all by itself, we'll divide both sides by PT. And there goes the P, there goes the T. And then that means R will be equal to A minus P over PT.
In reviewing what we did on the whiteboard for example number 6, we used this hint to use the distributive law to free up the R. So we had to distribute the P times 1 and then P times RT to get A is equal to P plus PRT. Then we subtracted P from here because remember we want to isolate R. And then we divided by PT in order to get R all by itself, and we ended up with A minus P over PT is equal to R. In example number 7, if A is equal to 2x plus P times x plus R, solve for x. So let us go over to the whiteboard and solve this example for x.
In example number 7, we are given A is equal to 2x plus P x plus R, and we want to solve for x. Well, we can do, first we can bring the 2x over, but we don't want to do that because we have x here twice. So what we want to do is we want to first do the distributive property. We don't want to just bring things around and around in a circle. So because we want to be able to collect up all the x's so that we could solve for it the way we would a regular algebraic problem. So what I'm going to do is I am going to use a distributive property and multiply P through and free up the brackets as I did in the former problem. So I end up with 2x plus px plus pr. Now I can bring the rx over to this side, so then I have the x's on one side and the non-x's on the other side. So here I have minus pr, and then I get a minus pr is equal to 2x plus px x. Now what I can do here to get x all by itself is I can actually use factoring, and I can factor out the x. So what I could do is a minus pr is equal to x 2 plus p. And now I can divide out the 2 plus p in the bracket here and get x all by itself. So I put 2 plus p here, down here, and whatever I do to one side, I must do to the other. And here we go. And that means that we have x is equal to a minus p r over 2 plus p.
So let us review what I just did on the whiteboard. This is a bit trickier since x shows up twice. So we used the order of operations, the distributive law, and collecting like terms to do this. And we got a is equal to 2x plus px plus pr is equal to x bracket 2 plus p close bracket plus pr. Note how I factored out the x. This is very important in this example. So here I got a minus pr because I brought the pr over to the side with the a, and that's equal to x times 2 plus p. Now I can divide both sides by 2 plus p in order to isolate x, and I end up with a minus pr over 2 plus p, and that is equal to x. In example number 8, I'm asked to solve for x in this situation. I have c is equal to ax over x plus 3. So let us go over to the whiteboard and see how I would solve for x in a situation like this.
In this last problem, or example, number 8, we want to solve for x in this particular situation. So we have c is equal to ax over x plus 3. Now, of course, we could clear the denominator because we have a fraction situation, but I'm just going to use the ratio method because in a way that's simpler and faster. So I'm just going to put a 1 underneath here and cross multiply because I have an equal sign between these two ratios, and then I'm going to solve for x. So I'll cross multiply, so I'll end up with c times x plus 3 is equal to 1 times ax, but we usually don't write the 1, and I'm also going to distribute these two like I did in examples 6 and 7. So I'll end up with cx plus 3c is equal to ax. Now what I will do is I'll bring over all the x's on this side. So I'll subtract cx, just like I would if this was an algebraic problem with numbers. And I end up with 3c is equal to ax minus cx. Now, in order to isolate the x's, well, I'm going to factor them out. So I end up with 3c is equal to x, a minus c. And then, of course, to get the x all by itself, I'm going to divide the whole thing out by a minus c on this side, a minus c on this side, so I can cancel out on this side and end up with x being 3c over a minus c. And that would be our final answer.
Reviewing what we just did on the whiteboard, here we have a ratio. So this means that we can cross multiply, or we can clear the denominator if we like. But in this case on the whiteboard, I used cross multiplication because it's easier and quicker for this particular example. So I just cross multiplied. And I got C times x plus 3 is equal to 1 times ax, which is the same thing as ax. And again, as before, we need to free up the x. So we use the distributive law to do this. So we multiply c into the brackets. Cx times c3 is equal to ax. And then we got all the x's on one side. Then we factored out the x and divided to isolate the x. So here we factored out the x, and then we divided a minus c to isolate the x. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.